Hello everyone, let's look at today's Leetcode problem 2901, longest unequal adjacent group subsequence. Before starting this problem, let us look at a motivational quote for today. If it doesn't challenge you, it won't change you. So if we are always in the same level of uh, challenging problems, then we won't be moving ahead. So we should always take up problems that challenge us, and we should try solving them even though we feel uncomfortable at the beginning. Okay, so let us understand the problem statement. You are given a string array words and an array groups, both having length n. The Hamming distance between two strings of equal length is the number of positions at which corresponding characters are different. You need to select the longest subsequence from an array of indexes 0 to n minus 1, such that the subsequences denoted I0, I1, k having length k. The following holds good. The adjacent indices in the subsequence, their corresponding groups are unequal. So corresponding groups are unequal is something that we even saw in the part 1 of this same of the problem, and we have a new term called Hamming distance. But let's continue to the point 2. Words of j and words of j plus 1 are equal in length, and the Hamming distance between them is 1. So words of I and words of I plus 1 should be same length, but Hamming distance is difference of characters from these two words should be 1. So Hamming distance should be 1. Let's call this difference in short way, where only one character is different between these two words. Return a string array containing the words corresponding to the indices in order in the selected subsequence. If there are multiple answers, return any of them. Okay, so let us look at the example and let's try understanding this better. So we have words, these words, and we have index groups for them as such. So if we try looking at this array and we look at this groups, so we have two conditions. So condition 1, group should be different, and condition 2, word I length and also we have in the same condition 2 we also need to check Hamming distance. This is nothing but difference of characters. So these are the conditions to uh, add into a subsequence. So let's consider DAB as a possible value, and we can check from DAB we can check if BAB and DAB. So these two groups are different, and also there is a difference in one character, which is B and D at the first position. So BAB and DAB can possibly be a solution, while BAB and CAB cannot become a subsequence as they have same groups. So we see either BAB or CAB can be a possible solution, right? That's that's the same answer that we see here. So either BAB or BAB or DAB or CAB. Fine. Let's look at an example 2 where there are these set of characters. So the words can even contain string as we saw before, but there is a specific constraint that we should be knowing. So n, which is either length, can be less than or equal to 1000, and each word of I can be less than 10 or equal to 10. So and groups of any specific value can be less than 10,000. Okay, so we have an idea on what constraints we have, right? So let's look at this example too, where these are the single characters, while in the previous example we saw a set of characters or a string, right? So here we have altogether different set of group numbers, and we can say all of these would be a possible subsequence, if you see, right? And that would be a longest subsequence. Okay, let's look at the thought process on how we can solve this problem. So in the previous problem, we went with an approach where we had a for loop which iterates 0 to length times, and we were just keeping track of the lengths which we were just pushing the numbers to a resulting array if their groups. And this was a greedy type of solution. And this approach would not be a valid solution, or this would not lead us to expected output. We can take a look at a specific example. Let's say we take A, B, C, and A, C, C, and A, D, C, and A, E, C. So let's try, and there will be group numbers 1, 2, 1, right? So let's walk through the solution. Let's say if we consider ABC and if we move on to ACC, so this is a valid pair as these two for the subsequence. And now from ACC to the next possible word, which is this one, there will be no possible pair as the difference. uh, ACC, from ACC we do not have a valid answer, so we cannot include ADC and also AEC, while if we had chosen and if we had skipped ACC and if we had chosen uh, the others, which is, so let's say instead of choosing starting from ACC, if we had chosen ACC, and ACC and ADC would have been a possible candidate, and ADC and AAC would also have been a possible candidate. And if we see ADC and ABC had two groups which are same, so the initial group that we would have stopped would have been with greedy, we would have only ended up with ABC and ACC. If we would have ignored ABC, we could have ended up with these set of pairs, which is ACC, ADC, and AEC. So these would have been a possible pair if we would have ignored, or if we would have started from ADC checking this one and this one, right? So let's such examples uh, would be best solved with dynamic programming, where uh, in dynamic programming we try all the valid paths, and the longest sequence ending at each index will be considered. And let's look at the same example where we had words A, B, C, A, E, C, A, C, C, sorry, and A, B, C, and A, E, C, and 1, 2, 1. And if we would have chosen dynamic programming problem, so let's say usually the answer to this one would be this one in case of dynamic DP solution. And let's see how we can come up with such answer. So the solution approach in dynamic programming is, firstly we initialize certain uh, array for DP array with the length into all ones, and then we would be having a previous array which would have -1 uh, as a pointer to the next previous index to the specific DP index. And similarly, we to populate these values, and initially we start off with the max index 0, and we also would be have it. So now for the calculation part, we would be starting off with I, which ranges from 1 to n minus 1, and we would be having a nested for loop which goes from I to I minus 1. And here in this part we do a check for all of the conditions that we had with respect to uh, groups and length of the word equal, and difference or the having is equal to 1, right? And then we check if dp of the specific index plus 1 is greater than dp of specific value, and then we add the max index, we update the max index in the dp array, and then we get the values. So let's try implementing this solution. So we update the previous index with the j value here. And yeah. So let's see if we can implement the solution, and let's go to our Leetcode editor and try solving this problem. Okay, so we are going to start off with two constant variables, getting the length of the words, and we are going to create a function which calculates the difference. Let's call this check difference. This would be for the having difference which should be equal to 1 as per the second criteria. And let's say this function takes an s1, s2, here we are going to get a difference of the two characters, and let's start initializing the DP array. And this would keep track of the previous index if we find any u value. This would be less than I, and we check if, let's say firstly we check if the groups of I is not equal to groups of J, that is the previous string. Then we check the lengths of the two strings are equal. And we check the difference of these two. This should be of exactly, well, so these are the three conditions that were listed here. So the words, the two word strings at specific index should be of equal length, and the having distance, which is the difference or the number of characters difference between those two strings, should be of 1. And once we do that, we also check if dp of j plus is greater than the current dp. So this means we are having to check if the previous one has a greater subsequence, and we are having to update the current index. And we keep track of the previous index just so that we can, during the time of return, so we get the previous index values, and from there we can pick the words at the specific index that we were looking for in the result, right? So let's find which has the maximum subsequence from the DP array, and we shall do the result string which we want to return from this function as an answer, and let's say we go backwards in the DP array, checking all the values that form the subsequence with the max index and the previous setup value. So let's try submitting the solution. Let's see what's going on and why we are having to raise an issue here. So let's see one of these let's not try submitting the solution. Okay, as you can see, the solution gets submitted, but with respect to time and space complexity, we have two for loops to calculate or to have the DP values arranged, and also another for loop which is used for calculating all the result values. So time complexity would be O of n square plus, let's call length of the array of previous index, previous matrix. So, and we would be having two arrays which would be of length n, so it would be 2n or just n. Alright, that was time and space complexity. If you